Hi, for my graphics final project I decided to do collision. As you see, I can't walk through a wall, but when I walk in a direction that is not orthogonal to the wall, I will slide across it. The way this was done was by projecting the movement onto the plane of the colliding wall and then checking for no further collisions, which allows me to walk up ramps like this. I additionally implemented player gravity, so the player can jump around, and he'll fall, and he can fall out of the map, but he will then be sent back to the start. And the way I accomplished this was by representing the player by a series of points in a solid 3D body, the series of points to allow for easier collision resolution, and the solid body to make sure my player can't fall through triangles like the ones I'm standing on right now. In addition to the player body, I implemented a collision body to represent bouncing balls, which you can create by pressing B or by clicking to throw them more violently. Here, let's take a look at some of the balls. So when you throw them, they bounce and their bounces dissipate, and when they will slow down to a roll at one point, at which point you can see their textures start rotating corresponding to how much they're rolling. I've also implemented a feature to make it rain balls by pressing R, which is always a delight to watch. Here, let me step back, but if you make too many, it starts to hurt performance. And you can press I to invert gravity, and I to set it back, and G to get rid of gravity. And if all the balls go too far, they automatically get deconstructed and their memory gets deallocated. One challenge I faced in the project was trying to get the balls to seem realistic. I'll show you some of the tricks I used to make them seem more real. First off, the ball is represented by a series of points instead of an actual sphere, which allows collision detection to be done easier. Speaking of, the way collision detection was done was by using the Muller-Trumbore intersection test and having the line segment be start at the point and move by according to the force, and then the collision resolution was done by when a collision was detected to reflect the force across the normal of the colliding wall to give a bounce effect. Another trick I used was by adding a little randomness in the X, Y, and Z so that the ball seems more realistic. Another trick I want to highlight is that instead of the ball having one collision body, it has two, one which bounces and one which rolls. And it switches off from the bouncing one to the rolling one if the acceleration due to gravity is equal to the acceleration due to normal force, basically meaning that it's on a surface. One final trick I want to highlight is that how I did rotation. Well, I crossed the normal vector with the movement vector to find the axis of rotation, and then the amount by which I rotated it corresponded to the length of the movement over the circumference of the circle to get the actual real length it would rotate and give it quite a realistic effect. There were other tricks I used to make everything more efficient, but that's just what I wanted to highlight.